A block slide at constant speed down a ramp while acted on by three forces. Its weight is the normal force and kinetic friction. Respond to each statement true or false. The combined net work force by all three forces on a block equals zero. Each force does zero work on a block as it slides. Each force does negative work on a block as it slides.
This type of question from the textbook, we have come across many of these type of questions. It is actually a question, then they have many parts, then they ask you true or false. But it is from this question that you will make you understand the concept behind, right? So I'm going to explain to you one by one. Right? Now there is a block, right? This block here, why cannot? Okay, this blue color block is placed on an inclined plane, a ramp. They call it a ramp. Actually, we call it inclined plane. So it's placed on top of an inclined plane, and this block slides down the inclined plane with a constant velocity. With a constant velocity. So the fact that they say constant velocity, that means there's no net force. All the forces, they balance one another. There's no net force. Not like these cases here. That got net force, this one got net force. This one has no net force. Now, what are the forces acting on this block so that they balance one another? So the three forces acting on this block here, they are: number one, the weight of the object; number two, the normal reaction; and the third one is the frictional force. These are the three forces acting on the block, which is sliding down the inclined plane at a constant velocity. Right. Well, you have to take note of this constant velocity here. Constant velocity means the net force is zero. All the forces, they balance one another. What are the forces that balance one another? Frictional force, normal reaction, and weight. Okay. The first question, the combined net work, or two words correct, the combined net work done by all the three forces on the block equals to zero. Is that correct? Net work is zero. Where does the network come from? The network comes from the net force. The network comes from the net force. Comes from the net force. Not only from the net force, but multiply with the distance of delta x. We call it d lah. Multiply with the d, or just put down d in our. So when the net force is zero, the net work done will also be zero. Because the net force is zero, multiply with d, the answer is also zero. So they ask, hey, the combined network is zero, they say. So what is your answer? True or false? They say the net work done is zero. True or false?
True.
True. True. Why? Because the net force is zero. Net force times the distance also zero. This is true. Right. However, if you look at them individually, that means when you look at one force, let's say the weight alone, the weight is actually not balanced by other. When they are not balanced by other forces, they're actually doing work. Or if you look at the frictional force alone, the frictional force, if they are not balanced by any other forces, it is also doing work. So if you look at them individually, they are actually doing work, but they cancel one another. One is a positive work done, the other one is negative work done. That's why they cancel one another, right? Okay, so the first question say net work done, is it zero? Yes, net work done is zero because the net force is zero. The second question, each force does zero work on the block as it slides down. Or if you look at them individually, they are not doing zero work. Only one person is doing zero work. Who is doing zero work? This one, this one, the normal reaction. Why the normal reaction is doing zero work? Because the normal reaction is pointing perpendicular to the plane and the object is moving parallel to the plane. So this force perpendicular to the motion, proportion of perpendicular to the displacement, so it's not doing work, right? Only the normal reaction is not doing work. Now, if you look at the frictional force, the frictional force, the frictional force is going up and your object is moving down, but they are parallel. So this frictional force is actually doing work. Is doing negative work because it is pointing up, whereas your motion is moving down. So this frictional force is doing negative work. It is doing work, right? It is not zero. Then we look at the weight of the object. The weight of the object, it has a certain component parallel to the plane. We call it mg sine theta. The component that is parallel to the plane is mg sine theta. Mg sine theta. Now this component is actually in the same direction as the motion. So this component is actually doing work. The weight of the object as a whole is doing work. So you cannot say that all the three components, they are not doing work. Two components doing work, the normal reaction not doing work, that's all. Okay, so the weight is doing work, the frictional force is doing work, normal reaction is not doing work. So my answer is only n does zero work because it's perpendicular to the direction of motion, right? The third part, each force does negative work on the block as it slides down. Not each force. Each force means every one of them doing negative work. No, not everyone. Only one of them only this component. The frictional force is doing negative work because the frictional force is pointing upward and the motion is downward. So the frictional force is doing negative work. This component, mg sine theta, this component, mg sine theta, right? Mg sine theta is doing positive work because mg sine theta is acting downwards and the direction of motion is also downward. The displacement is also in the downward direction. So this component is doing work, right? So if they say each of them doing negative work, not true. Only one of them doing negative work, the other doing positive work, the other one not doing work. Okay, right? So this A is true, B not true, C also not true, right? The reason I have put down there, friction is doing negative work because it is in the opposite direction as the displacement. Right? The other one is not doing negative work.